Hi, welcome to our math and my series of videos on finance equations. For this first example, we have Catherine who's inherited $4,500 and she wants to invest it for 40 years. Just put it in the bank and forget about it. She has this big lump sum. So she's found several banks with different options. So for our finance formula, P stands for the initial amount invested, R is the rate per year, N is the number of times it compounds a year, and T is the number of years. So for all of our examples here, the principal is going to be this $4,500. For all of our problems, the time is going to be 40 years, and then each bank is going to offer a little bit different options. Our first bank has 5.9% interest. That doesn't mean she gets that every month. It means that's the yearly interest. 5.9% we need to turn into a decimal, so we divide it by 100 to get 0.059. And then compounded monthly, this N stands for the number of times we compound each year. So in this case, monthly, there are 12 months a year. So when we put this together, we have A equals $4,500 times 1 plus 0.059 divided by 12. So what's happening is, because this is compounding monthly, but we're trying to calculate yearly, we take the 0.59 yearly rate and divide it by 12 to figure out what chunk of 0.059 gets applied each month. Now, because it's getting compounded monthly and the money is getting added in each month, instead of the money accruing interest for 40 years, it gets money 12 times a year for 40 years. So the number of times the equation is applied, 12 months a year, 40 years. If we throw this into a calculator, we find out that her $4,500 becomes $47,384.48, which I think is a nice investment. She had to leave it for a long time, but she got a lot of money out. If she chooses bank B, what happens is the P and the T stay the same, but now R becomes 0.061, and it's compounded daily. And so for daily, I'm going to use 365 days a year. So A equals the 4,500 will stay the same. 1, because that represents 100% at the beginning of each day. Now the 0.061, our rate as a decimal, has to be divided up 365 times. That gives you very little each day, but every little bit adds up. Now, how many times does this get applied to the 4,500? Well, it gets applied 365 days a year for 40 years. So that exponent has to take care of the total years, but you have to do the chunks per year times years. If we throw this into a calculator, we find out at the end of 40 years, she has $51,000, well, $51,618.16. Notice I'm always rounding to 2 decimal places. That's what we do with money, and it's important that you always round to 2 decimal places. You see that just 0.2% interest raise and a bunch more compounding got, over $4,000 more. So that's a nice return on a tiny change of investment. All right, for this last one, it says Bank C offers 6.25%, that's the biggest, compounded quarterly, that's the smallest. So now R is going to equal 0.0625, and N is going to be 4. Quarterly means 4 times a year. Our P is still 4,500, our T is still 40. Those numbers aren't changing. So we have A equals our 4,500, 1 plus 0.0625, and this time we just divide it by 4. And then 4 times a year for 40 years, Catherine will get from this bank $53,771.70. So where compounding more often is great, interest trumps everything. For her last bank, Bank D, offers 5.75% compounded continuously. So for continuous interest, we switch to this equation. E is a number that is calculated by doing this equation with everything one'd out, 1, 1, 1, and taking t out as big as you can get, and you calculate E. So E is our finance variable. Like pi, it is just a number. Pi is a number, 3.14. E is a number. So if we're going to use this once again, her initial is still 4,500. Her years is going to still be 40. But now her rate is going to be 0.0575. And we don't need an N because it's happening continuously. So A is equal to the initial $4,500 times E to the RT, 0.0575 times 40. If we throw this into our calculator, we find out at the end of 40 years, she will earn $44,883.82. So even though it's continuously being compounded, the interest rate is half a point less than bank C, which is why often when you hear people talking about loans and everything, they don't really talk about how often it compounds. They talk about what the interest is. Compounding does matter. I mean, from A to B, you saw a huge difference, and it wasn't a huge difference in the interest rate, but it was a big difference in how often it was applied. I hope you enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.